for TESL and AI Native DevCon. The organization here has been just amazing. I'm Ray Myers. Welcome to AI Hates Legacy Code. Now, people sometimes ask for my slides. You can find them at raymyers.org/talks. I currently work at OpenHands, the leading open source coding agent, which as of yesterday is officially a Series A startup as well. I've also worked at some places you've heard of. Coding agents are cool. We all can agree on that. What isn't cool is if one deletes someone's production database, despite explicit instructions not to. I don't consider that cool. As happened to someone a few months ago, you may have heard, or when, for instance, it edits your make file to make the test report passing even when they've failed, as happened to me while I was preparing this talk. This is a true story. Now, these quirky behaviors relate to model behaviors that we've given names like reward tampering and hallucinations. These are things that the leading model labs like Anthropic have been trying to stamp out for well over a year. But despite their efforts and some progress, this is still like a very regular part of your experience if you're using coding agents downstream of the models. And if you're an agent builder like myself, these represent bugs we can't fix. We have no path to fixing these bugs under our present assumptions. So do we need to change those assumptions is the question I'm raising. And people have different ideas about that. It depends on what your needs are, honestly. Perhaps you're from the land of demos, the land of prototypes. You're from the land of new code, some of you. And therefore, you are from the land where, above all, AI works. You may not have a problem. You're from a place I like to call pitch deck paradise. I've tried to draw a representation of it. It's a strange place to me. I imagine it as fields of green because you do greenfield development. There's a pot of gold there. I know that's very important. Maybe you've got like a magic mushroom house. I don't know your life. I'm from a different place. I'm at a startup now, and it's not my first, but I am from Legacy Mountain. When people are from different places, it's sometimes hard for them to communicate with one another. And so I like to wrestle with the dialogue that I've been seeing over the past year or so. People from Pitch Deck Paradise will say that AI coding is a game changer, and they are reporting their true lived experience. They are right. Whereas people from Legacy Mountain will hear that and say, your AI doesn't work. And they are also right. They are reporting their true lived experience. But people from Pitch Deck Paradise don't understand how someone's experiences could be so much different from theirs. They say, you must be closed-minded. This must be the issue. And start blaming the users. But it still is a thing that doesn't work in their world. This does nothing to help the situation. And then they will try and threaten us. And they will say, you will be left behind. I have seen hundreds of people say, you're going to be left behind. As though I'm in the freaking Rapture or in a B-movie franchise starring Kirk Cameron instead of trying to have a nuanced technical discussion. Threatening also doesn't make it work. It just doesn't work. We're reporting. What will help is if the dialogue becomes, let's fix it. And that's the dialogue I want to have, so I declare a truce. There have been some harsh words on both sides, I'm sure. Heart emoji, handshake, whatever you need. On behalf of Legacy Mountain, I welcome you because you are trying to climb Legacy Mountain. And I respect that. We need all the help we can get. There is some disagreement about how far up it we are. For instance, we have these great benchmarks like SWE-bench, which is representative of real tasks that had to be done on real GitHub repositories. And I think there's strong consensus, the fact that we have many agents now exceeding 70% at what's called the verified subset. These kinds of benchmark results represent real economic value. These are not vanity metrics. But how does this translate? How far up the mountain are we? Does 70% SWE-bench mean we're 70% up Legacy Mountain? Some people talk as though that's the case. It will get you some shares on LinkedIn, I'm sure. Others, and I'm closer to this view, feel like this is actually 70% up something pretty interesting, but it's so far down the bottom that you can't even see the top from where we are. So, Legacy Mountain we'll find is a treacherous place. Sometimes it could feel more like this mountain. And you may not want to look at that. You may not want to think about that. I don't blame you. One does not simply walk into Mordor. But we have no choice. The code was forged in the fires of Mount Doom, and only there can it be unmade. And just like Gandalf said, I am not trying to rob you. I am trying to help you when I say AI hates legacy code. So this would be a good time to define terms. What could I mean by this? In this context, what I mean is systems based on large language models are ill-equipped for the challenges of existing production code. AI, of course, can mean many other things. They don't literally hate anything, but in this context, I'm talking about the current assumptions building coding agents. This is what I mean the challenge is. Now, I've said legacy code is any existing code in production your business depends on. There are particular pieces of legacy code that are usually referred to in this way because they are challenging. And so when we talk about the legacy code challenges, it's usually some combination of it being old or archaic, done in an old way we wouldn't do now. Brittle, it breaks easily. It's untested. It's forgotten. We're missing some context. Some people have moved on. But all this boils down to, we fear to change it. If on pitch deck paradise you believe we're afraid to adopt AI, you're partly right, there is fear. But it's actually a sadder situation than us being afraid of the new technology. We're afraid of the old technology. We're afraid of our own systems. In software engineering, the reality in the industry is we are quite literally afraid of our own legacy. That's what you're walking into. Good luck, I'll try and help you. Now, why is this a problem for large language models specifically? You've probably heard throughout 2023 that it is easy to get large language models to give you good value when the tasks have certain properties. Like for instance, I can ask ChatGPT to give me a silly goose, I get a silly goose. Okay, very good. But more generally, tend to excel when it's low risk, there is a clear context, and it is easy to check the result. I looked at it, it's clearly a silly goose. Okay, fine. Actually, there's some dispute on this. Opus has claimed it's actually a duck. We'll look into that with an avian pathologist and get back to you. So, regardless, in Legacy Mountain, it is often the case that the exact opposite is true. It is a high-risk task because you're, by definition, working on something your business depends on. There is an unclear context, and the result is not easy to check. So, LLMs fail, or if they don't, they require these elaborate workarounds to manage the risk. So we see our experience is so different because we have different needs. And what we don't need, I claim, are excuses. I have been hearing some excuses, not to point any fingers in the direction unnecessarily of any particular people in pitch deck paradise, but these things are in the air. One, the models will get better. This, while true, I claim is an excuse because the models don't get better in every conceivable way imaginable equally, which is, I think, what this is a placeholder to mean. We have seen very clearly they get better in some dimensions and not in others. If you're going to make a statement like the models will get better, I would say maybe specify what behavior you'll think they'll get better at, and how will you know when they're there? I think this has become too big of a panacea to wait for. Another thing that's said is humans make mistakes too. Again, technically true, and somewhat useless. This is a thought-terminating cliche. Humans do make mistakes, and we have to deal with the consequences of that. And LLMs are not people. They make different mistakes for different reasons. So if you're using this at the beginning of a statement and saying, and how do we problem solve from there, fine, not an excuse. But don't use it at the end of the thought. That'd be a thought-terminating cliche. Then we have blaming the user. Now we're going to establish these tools are very confusing to get real results on in many realistic contexts. So if you blame the user for not knowing your latest 20 tips, tricks, and techniques, you're ultimately just holding back your product from getting better. Empathy for the users will produce innovation that gives us better experiences. So, we're done with the excuses. Let's talk about getting better. There's two people we could be talking to, two groups, though they do strongly overlap. A user of coding agents. If you're not interested in building and improving the agents we've got, but you want to do better using, I do have some words for you. But also we're going to talk about getting better as tool builders. As a user, I would say apply software craft. You can learn how to use AI. That's great. I'd like you to do that. But there is still something happening here that is kind of just the physics of the situation you're on. You can call it software craft or software engineering. And we've had it for a long time. Most of it's still relevant, and most importantly, we know how to teach it, so you have a clearer path to learning that. When I say apply software craft, some starting points. These are some books that I would highly recommend. Working Effectively with Legacy Code, Michael Feathers. Kill It with Fire, Marianne Bellotti. Modern Software Engineering by Dave Farley. These are some people with blogs and videos I find very useful as well. If you've got some legacy code challenge, people like this have probably said something very helpful to you that you could go and seek out. And then you'll be able to apply that insight to use your AI better as well, if that's what you're doing. Are there resources for craft plus AI? Well, we're not quite so far along where we understand how to teach it, and the base knowledge is changing so quickly, but I would like to call out some work. Lotta Kessler gave a fantastic masterclass yesterday morning. She's here in the front row, so thank you for this. And she has an amazing GitHub repository that she and others, including the Simon Technical Coaching Society, have contributed to, where they're gathering, here's what we have learned to do to use coding agents in a way that's very principled with what we know about software engineering as well. This is a sampling of her talk from yesterday. This is just a map of just the things she was able to cover in the first 2 hours, with the masterclass. It's just scratching the surface of the workarounds they've cataloged. This should tell us something about the tools. We could start taking lessons from this so that people have to memorize fewer workarounds very clearly. So these coding agent skills, they often have to do with managing context, managing the risk, either using these software craft skills or by reducing the task size, things like this, or they're customizing how you're using the agents. Your agents all have some amount of customizability. You should learn how to use that. Something we've just announced in OpenHands version 1 is we've extracted out the core agent that makes the box tick into something called the Software Agent SDK. So this will allow you to start scripting how you're using the agents with actual code. You're not limited to only prompting. I think this is very important for reasons I hope will become clear. But generally speaking, learn to customize the tools you're using because they're really not a complete experience for the full range of tasks you're going to see. Getting better as a tool builder then is help your users, which I hope would be obvious. Help them to apply software craft, which is the goal. Also help them understand your tool with clear, predictable behaviors that they can learn and that they can trust. Currently, our tools are a little bit too much like a magic box. On Legacy Mountain, we don't need a magic box. We need a wrench. I know what it does, and it fits in my hand. So how do we do that? Let's go back to this central challenge I'm arguing we're facing, that solutions based on large language models are ill-equipped for the challenges of existing production code. If we take that as not just a defeatist slogan, but it is some non-temporary state of affairs to contend with, it does suggest solutions, right? Perhaps our solutions should not be based so much on large language models. Perhaps we should just reduce our dependence a little bit. Let's talk about what that means. I'd like to simplify the domain of components we can use into two axes: scope, how general they are, and confidence, how confident we are in what they're doing. Language models, the big ones, the frontier, the foundation models, if you like, they are very high in the scope of what they can attempt to do. That is super interesting. It's understandable. We're excited about that. Algorithms, on the other hand, as well as the old school symbolic AI, we're highly confident in what they are doing within the tiny scope that they've been designed for. And so if you're trying to reach that upper right corner where you have a wide scope and high confidence, then you can try to take LLMs and push higher confidence, or you can take algorithms and try to level up in scope. And a lot of excitement, a lot of money in this angle, right? Try to push it all through LLMs by improving the LLMs, raises all boats. But as engineers, we're not limited. We can do both. We can use these both together in kind of infinite combinations. So that's the shape of things, in a nutshell. Here are some examples of that. Again, what we're trying to do is give these tools clear, predictable behaviors that people can learn and understand and trust. Allow our users to form a mental model. My first time addressing AI native dev, I came to New York, February, and I gave this talk, Make Tools That Don't Break, about working with some code like this and worse, using refactoring algorithms. There's another talk that's coming on right after mine by the CEO of OpenHands, Robert, and it's called Managing Fleets of Coding Agents with OpenHands. I'll mention a taste of what's in that, but it talks about our approach so far on these long horizon tasks. We say these larger code bases that present these problems. Another one I'd like to call out that's also right after mine, so watch one online and one in person, I guess, is DevOps agents that can't delete your database by my friend George from StackPack. I love that premise. So the first one of mine I just mentioned, that's refactoring code safely by algorithm, not seeing humans or LLMs as the things that should directly be editing the code. The Roberts involves breaking down tasks by studying the source code and making this dependency graph before we give tasks to agents, this fleet of agents. And George's is about using a policy engine to enforce what the agent does. Or at least that's the part of the technology I'm highlighting. So if we combine those first two ideas, as sometimes we do in some of these OpenHands migrations we're looking at, then we've got static analysis of the source code, making this dependency tree, and coming up with then how are we going to partition out and order these tasks so that we can address them with agents in parallel, but they're set up so they don't crash into each other. They have responsibilities where they're unlikely to kind of overlap, right? So we're setting the task up for success. Then we have our little worker bees, the fleet of agents, doing what they do. But then on the end, when we're editing the code, where possible, we can still do that with syntax transforms just through agent tool use, using tools like AST-grep, Java parser, and others. So interesting thing there. This is like turning a compiler inside out. There's an LLM-based agent, but the rest of what's going on looks like the inside of a compiler. That's because compilers are really good at thinking about code. And LLMs, it turns out, are not compilers. That's my opinion. Maybe that's the next talk. You give me a time check here. I'll break down. We good? Perfect. So I'd like to then break down a little bit of some of what makes George's engine tick. And I think this will be a little deeper up the stack than the things he's going to cover in his talk. But StackPack is a DevOps flavored coding agent. It has a lot of domain specific stuff they're targeting for operations domains. And it has internally a permission system called Warden that uses Cedar policies. Cedar is a technology made by Amazon for enforcing policies in this domain-specific language. An interesting thing about Cedar is formally verified, meaning there are aspects that are mathematically proven, which I will show you. To my knowledge, this is the first use of formal verification in a coding agent product. And there are many research examples. I think this is the first example that went all the way to production. Let me know if I've missed one, because I'm cataloging them in a little repo called Awesome Verified Coding Agents, to kind of track these emerging efforts. Because I just want to highlight this really advanced use of algorithms together with LLMs to deliver these high assurance experiences. What does this look like up in Amazon's Cedar, right? It's an open source library that parses this DSL, domain-specific language, about what people are allowed to access, what resources, and so on. So we've got a forbid there and a permit there. And then there's code in that engine written in Rust, right? So we say we authorize things, and it's executing a particular bit of logic there. Like if something is marked both that it should be forbidden and that it should be permitted, then forbidden should win. Right? This is a piece of logic they'd call forbid trumps permit. And it's very important to them that that code does what we've just said. If it didn't, it would be a big problem. So they want to make extra sure, not just for the inputs we're going to test on, but actually for every conceivable input we could have. There are ways of doing that. The way they've done it here is they've implemented a reference implementation of that Cedar engine that's in Rust. They've got a parallel implementation that's in a language called Lean, which you can do mathematical proofs on. Field mathematicians use it to verify their results these days. So they've got, a slightly translated, kind of purely functional version of that isAuthorized method. And then, because it's in Lean, they have a theorem about that. And there are almost 2,000 such theorems in the Cedar spec codebase, where that top part is basically code as you'd understand it, just knowing that the arrow is an implies arrow. If you were to look at it for longer than I'll have it up, you'd understand. But the rest of it is something that might be new to some of you, which is called a proof script. It's a series of tactics that are used to prove that statement. This is just one step of that. I won't walk you through the whole proof right now, but this is a short, understandable one. When you use this in an interactive theorem prover, which is what I spent a lot of the last year studying, there's this thing on the right-hand side called a proof state. And you look at the current state of the goal at the bottom you're trying to prove. You'll notice it has that isAuthorized function referenced. So there's going to be a tactic executed here. Someone has looked at that and said, what I need to do is inline isAuthorized. I need to start to explode the definition of that into my proof state using, it's called unfold in the language of these theorem tactics. And then I have the definition of it there, and I can start doing further steps, manipulating it and simplifying it so that I've proven the end result. So this is like tests, but can prove things for all possible inputs, not just the inputs in the tests. So how many of you have seen a tactic prover before, an interactive theorem prover like that? Okay, at least one person. So the rest of you haven't, now you have. And there are endless possibilities. The entirety of computer science, past, present, and future, is at our disposal. The one thing we can't do is escape old code. Even if we escaped all the code that's old today, new code becomes old. So I hope as we climb Legacy Mountain, we can at least agree on this. Whatever techniques and magic and models and chicanery we use, let us work together to make legacy a word we can speak with pride instead of fear. Let that be our legacy. Thank you.